Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kindly refers to the question, evaluate the limit when x approaching negative infinity. For the function, we have the square root of x squared plus 2x minus the 3 over, we have the modulus x minus 1. So kindly define the situation where we have the modulus x minus 1. So where we have the definition, x minus 1, where we have x greater equals to 1. Negative bracket x minus 1, where we have x less than 1. So here what we have the definition. So locate the 1 for the left hand side, which means that x less than 1, we have the negative bracket x minus 1. For the right hand side, we have x minus 1. So that is the definition for modulus x minus 1. Next, kindly substitute the situation. So here, if we substitute the negative infinity, here we will have the positive infinity over, if we substitute the negative infinity for the denominator, we also have the positive infinity. Here we have the indeterminate form. The strategy will be dividing the numerator and also the denominator for the highest power of x by referring to the denominator. So for the denominator, we can notice that we have the modulus of x minus 1. By referring to the definition, for sure, the highest power for the denominator would be the x. So kindly factor out the x. So limit when x approaching negative infinity. So here we have square root of x squared, square root of 1 plus with 2 over x minus 3 over x squared. So meaning that for the numerator, we factor out the square root of x squared. Over, we have the modulus of x minus 1. So kindly simplify the situation. So limit when x approaching negative infinity for the modulus of x squared, or we can say we have the modulus of x. So definition would be x greater equals to 0, negative x, we have x less than 0. So again, illustrate the situation in a real number line, where we have on the left hand side, we have the negative x, and for the right hand side, we have the x. So notice that here we have the modulus of x squared, where we have the modulus of x. So based on the situation, we have the negative infinity, meaning that less than 0. So we have the negative x. So kindly substitute the situation. We have the negative x multiply with the square root 1 plus with the 2 over x minus 3 over x squared over. So referring to the situation, here we have the modulus of x minus 1. By referring to the definition, we have x approaching negative infinity. So meaning that focus on x less than 1. So here will be the definition. So we have the negative bracket x minus the 1. So kindly simplify the situation. Limit when x approaching negative infinity, we have to factor out the x for the denominator. So negative x square root, we have 1 plus with 2 over x minus 3 over x squared over, we have the negative x bracket, we have the 1 minus 1 over x. So if you simplify, limit when x approaching negative infinity, we have the square root of 1 plus with the 2 over x minus 3 over x squared over 1 minus 1 over x. So if we substitute the negative infinity, here we will have 0, here we will have 0, here we will have 0. So at the end, the value of y will be approaching 1. Next, kindly refers to the second question. A function h is defined as given. Kindly illustrate the h in the situation of real number line. So here we have the 1. X greater than 1. So where we have x minus 2, x plus with the 2, over, we have 2 minus the x. Here we will have the situation x less than equals to 1. So here we have the negative 3. So determine the continuity at h at x is equals to 1. So number 1, we have h bracket 1. So kindly refers to the real number line, we have the negative 3. So h1 is defined. Second step, find the limit. So limit when x approaching 1 from the left, from the function hx. So refers to the left hand side, where we have the negative 3. So the value of y will be negative 3. Limit when x approaching 1 from the right, refers to the function, we have x minus the 2, x plus with the 2, over, we have 2 minus x. So if we substitute the situation, then we will have the situation 1 minus the 2. Bracket, we have 1 plus the 2. Over, we have 2 minus the 1. So limit when x approaching 1 from the right for the function x squared minus 4 over 2 minus x. The value of y will be, so here we will have the negative 1, here we will have the 3. So here we will have the 1. So the value of y will be approaching negative 3. So limit when x approaching 1 for the left, we have the function hx, which is equals to limit when x approaching 1 from the right for the function hx. So we can say limit when x approaching 1 for the function hx, which is approaching the value of y negative 3, and the situation exists. Step number 3, h1 equals to limit when x approaching 1 for the function hx. So is it the same? So by referring to this part, we have the negative 3. For this part, we also have the negative 3. So we can say h1 is equals to the limit when x approaching 1 for the function hx. So we can say that hx is continuous and x is equals to 1. Next, we have the situation given y is equals to 2x minus the 7 over, we have the x multiplied with x minus the 4. By finding the limits at the appropriate point, obtain the vertical and the horizontal asymptote. Step number 1 is to find the domain. So by referring to the question, here we have all real number. Then here we have x cannot be equals to 0, x cannot be equals to 4. So the domain would be negative infinity until 0, union from 0 until 4, union from 4 until infinity. So here we have two situations. Number 1 will be the 0, number 2 will be the 4. Second step is to find the vertical asymptote. Limit when x approaching 0 from the left. Limit when x approaching 0 from the right. Limit when x approaching 4 from the left. Limit when x approaching 4 from the right. So kindly substitute the function. So here we have the 2x minus the 7 over, we have the x multiplied with x minus 4. Repeat for others. So kindly refers to the real number line, we have the 0 and also the 4. For the left hand side, we have negative 0.0001. Then we have 0.0001. Continue, we have 3.999 for the left. 4.0001. So kindly substitute the situation. If we substitute the negative 0.0001, so here we will have the negative. So here we also have the negative, and here we also have the negative. So the value of y will be approaching negative infinity. Next, substitute 0.0001. So if we substitute here, we will have a negative. Then here we will have a positive. Then here we will have the negative. So the value of y will be approaching positive infinity. So from here we can say that the vertical asymptote are, number 1, x is equals to 0. Next, if we substitute 3.999 into this part, then we will have a positive value. Substitute here, we will have the positive value. Substitute here, and we will have the negative value. Then we will have the value of y approaching negative infinity. Next, substitute 4.0001. Substitute in here, and we will have the positive. Same goes to this part, positive. Then for this part, also positive. So the value of y will be approaching positive infinity. Then we can say the vertical asymptote are x equals to 0, x is equals to 4. Next is to find the horizontal asymptote. Limit when x approaching negative infinity. For the function, we have the 2x minus the 7 over, we have the x squared minus the 4x. So if we substitute the negative infinity, then here we will have a negative infinity over the positive infinity. So where we have the indeterminate form. So the strategy will be dividing the numerator and also the denominator with the highest power of x for the denominator. So for this case, we have the x squared as the highest power for the denominator. So kindly factor out the x squared. So here we will have 2 over x minus 7 over x squared over, we have the x squared bracket 1 minus 4 over x. So if we simplify the situation, limit when x approaching negative infinity, where we have 2 over x minus, we have the 7 over x squared over 1 minus 4 over x. If we substitute the negative infinity into this part, we will have 0, 0, and 0. So as a conclusion, we have 0 over 1, where the value of y will be approaching 0 as well. Next, limit when x approaching positive infinity, we have the situation 2 over x minus 7 over x squared over 1 minus 4 over x. The value of y will be approaching 0 as well. So horizontal asymptote is y is equals to 0. So here we have the vertical asymptote, x equals to 0, x equals to 4. As for the horizontal asymptote, we have y is equals to 0.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.